Hello students, good afternoon, welcome again. In the previous lecture, we have discussed the application of p-n junction diode. Now, I am going to discuss the next application, that is the voltage multiplier. Basically, voltage multiplier circuit is the circuit which multiply the peak value of the input signal by n times. This means the circuit multiply the peak value of the input signal by 2 times, 3 times, 4 times and so on n times. This means the question arises कि what should be the components along with the diode should be connected so that it can multiply the peak value of the input signal by n times. So, obviously, there must be a passive component which store the voltage, which store the peak value of the input voltage Vm and maybe 2 Vm or 3 Vm and so on. This means that passive component is capacitor. Already we have discussed the charging of capacitor in the previous application, that is clamper, because the diode in combination with the capacitor is also known as peak detector, because once the diode is in forward bias, the capacitor gets charged till voltage Vm. On the basis of voltage multiplication, there are two types of voltage multiplier, that is voltage doubler and tripler oblique quadrupler. Voltage doubler is of two types, that is half wave voltage doubler and full wave voltage doubler. In half wave voltage doubler, we are taking the output voltage across the single capacitor. On the other hand, in case of full wave voltage doubler, we are taking the output voltage across two capacitors, that is C1 and C2. Now, I am going to discuss these three voltage multiplier circuits in detail one by one. Now, the half wave voltage doubler, this is the circuit diagram. In half wave voltage doubler, you guys can see that there are two peak detectors. This means two pairs of capacitor and diode. C1, C2, D1 and D2 are connected in this circuit. You can see that. This means the C1 will get charge voltage when the diode D1 will be in forward bias, and on the other hand, the D2 will get charge, the C2 will get charge when the diode D2 will be in forward bias. Now, already we have discussed in clamper circuit that the role of diode is just guest appearance. This means the diode gets on in one time only until and unless the peak value of the input voltage changes or the capacitor externally discharges. Otherwise, the diodes in these circuits, either the voltage multiplier or in the clamper circuit, gets on only one time. Now, there are two types of half input signal, that is positive half cycle and negative half cycle. We can see that when the D1 will be in forward bias, obviously in the negative half cycle. In negative half cycle, the D1 will be in forward bias and the D2 will be in reverse bias. This means the C1 will get charge in this loop. This means the right plate of the C1 will get positive charge and the left plate of the C1 will get negative charge as shown in this loop. And now D2 is in open circuited. This means what will be the voltage across the C1? By applying the KVL, we can write this equation Vm minus Vc1 is equal to 0. This means Vc1 is equal to Vm. Why the capacitor C1 will get charged, rapidly get charged till voltage Vm? Because the time constant through this circuit, this means the product of the forward resistance of this diode and the capacitance, this means tau RC is very small, because the forward resistance of the diode is very small. This means the time constant is very small. This means the capacitor C1 will get charged rapidly. This means it can charge till voltage, peak value voltage Vm. Now, after the capacitor C1 gets full charge, the diode D1 will be in permanently reverse bias. Why permanently reverse bias? Because if again there will be a negative half cycle, the peak value of the negative half cycle is Vm and the voltage across the C1 is also Vm. This means by Vm voltage across the capacitor, the D1 is in reverse bias, and input voltage by input voltage the D1 will be in forward bias. This means the D1 will be in permanently reverse bias, either the input voltage is positive half cycle or in negative half cycle, doesn't matter. Now in this positive half cycle, what will happen? The diode D2 will be in forward bias. Now the D2 will be in forward bias by the voltage of C1 as well as the voltage of the input voltage, because these two voltages are in series, in additive nature. This means Vm plus Vm, 2 Vm. This means the D2 will be in forward bias by voltage 2 Vm. Obviously, the capacitor C2 will get charged by 2 Vm voltage. Obviously, we can apply the KVL also. Now write the KVL equation Vm plus Vm. Vm plus Vm minus Vc2 is equal to 0. This means Vc2 is equal to twice Vm. This means in the positive half cycle, the C2 gets voltage 2 Vm. If we are taking the output voltage across V0, across the RL or across the C2, we get twice Vm. So it is called voltage doubler. But question arises, why it is called half wave voltage doubler? Half wave voltage doubler is because we are taking the output voltage only across the C2, and the C2 capacitor has charged during the only half wave, and this means only during the positive half cycle. That is why it is called half wave voltage doubler. On the other hand, there are another type of voltage doubler which is called full wave voltage doubler. In this circuit, now full wave voltage doubler I am going to discuss. This is the circuit diagram and this is the input, and there are two diodes D1 and D2, and C1 and C2 are across the output terminal. We are taking output voltage across the C1 and C2 simultaneously. Then later, when after discussing, after the working, I will discuss why it is called full wave voltage doubler. Now guys, we can see that during the positive half cycle, obviously the D1 is in forward bias, and during the negative half cycle, obviously the D2 will be in forward bias. Okay guys, so now I am going to discuss one by one. During the positive half cycle, the D1 is in forward bias. This means D1 is in forward bias. In the next circuit you can see D1 is in forward bias, and the capacitor will get charged till voltage Vm, because Vm is the peak value of the input voltage. Why? On the other hand, D2 is in reverse bias. This is the D2, and here this is the D1, and D1 is in forward bias, and the capacitor C1 will get charged in this loop. This means the upper plate of the C1 is positive charge and the lower plate, bottom plate is in negative charge, and the voltage across the C1 is equal to Vm if we apply the KVL. Suppose we apply the KVL here. What will here? Minus 2 plus, this means this is Vm, and minus Vc1, this is equal to 0, this implies Vc1 is equal to Vm. This means the voltage across the C1 is Vm. Now, once more, if the C1 once the C1 gets full charge, the role of D1 will be AND. The D1 will never become in forward bias. Either the input is positive half cycle or the input is negative half cycle. This means the role of D1 will AND. Now, the role of D2 will come into the picture. Now, when the input is negative half cycle, what will happen? Obviously, the D2 here, D2 will be in forward bias, because the polarity of the input signal is already changes. This means the positive plate is ultimately connected to this positive plate of the input, positive polarity of the input is connected with the here, and negative plate, negative polarity is connected with this. Now, the conduction of this circuit is as shown by arrow. This means the upper plate of the C2 will be positive charge and lower plate of the C2 is in negative charge. Now, if we apply the KVL, what will happen here? If we apply here, suppose we are writing the KVL equation from here, then what will happen? Minus to plus, this means this is minus Vm, and now here plus Vm, this is equal to 0, plus Vm, this means this is basically Vc2. This is basically Vc2. What will here? Vc2 is equal to Vm. Now, again the capacitor C2 gets charged till voltage Vm. After the charging of both capacitor, if we are taking output voltage across the C1 and C2, what will happen? If we are taking the output voltage across C1 and C2, it will become Vm plus Vm. This is equal to twice Vm. Twice Vm. That is why it is called full wave voltage doubler. And now, why it is called full wave voltage doubler? Because we are taking the output voltage across C1 and C2 simultaneously, and C1 gets charged during the positive half cycle and C2 gets charged during the negative half cycle. This means positive half cycle plus negative half cycle, it is called full wave. That is why it is called full wave voltage doubler. Now, I am going to discuss the another voltage multiplier circuit, and that voltage multiplier circuit may be called the universal voltage multiplier circuit. We can multiply the input voltage by n times also. The tricks of that circuit is that if we want to multiply the peak value of the input signal by n times, then we have to connect the n pairs of the diode and capacitor in this fashion. In this fashion, if we want to multiply the peak value of the input signal by n times, then we have to connect the 10 pairs of capacitor and diode. Since this circuit is the tripler or quadrupler circuit, that is why we have connected the 4 pairs of diode and capacitor. This is called one pair, this is called one pair, and this is the, this means there are 4 pairs of capacitor and diode. This means if we want to design a circuit to achieve the 6 times of peak value of the input voltage, that means we want to achieve the output voltage equal to 6 Vm, then what will we do? Obviously, we will connect the 6 pair of diode and capacitor in the same fashion. And if we take output voltage across the odd number of the capacitor, we get the all multiple and integral multiple of the peak value of the input voltage. Suppose if we take output voltage across C1, C3, we get tripler, and if we get output voltage, we take output voltage across C2 and C4, that is even number of capacitor, we will get even number, even multiplication of the peak value of the input signal. Suppose we want to get the output voltage by 6 Vm, then what will we do? Here we will take the output voltage across C2, C4 and obviously C6. This means we will get the 6 Vm output voltage. If we want to get 5 Vm, then we will take output voltage across C1, C3 and C5. So, this is the general criteria to design any multiplier circuit, any n times of multiplier circuit we can easily design. Now, working of this circuit, how does this circuit works? Suppose we are taking the input voltage here and the input voltage is like this. This is the input voltage, sinusoidal input voltage. Suppose this is half cycle number 1, half cycle number 2, half cycle number 4 and this is 3 and this is 4. Half cycle number 1, half cycle number 2, half cycle number 3, half cycle number 4. Here peak value is Vm. Now, you guys can see that half cycle number 1 and 3 are the positive half cycle. On the other hand, half cycle number 2 and half cycle number 4 are the negative half cycle. Then what will be here? For positive half cycle number 1, the sign convention is like this. Then what will happen? Obviously, in this condition, D1 and D3 may be in forward bias, but question arises, is D3 will be in reverse bias? The answer is D3 will be in reverse bias. Why D3 in reverse bias? Because if D3 will be in forward bias, then current has to flow through the C1, C3 and C2. On the other hand, D1, if D1 is in forward bias, only current has to flow through the C1. Once the D1 is in forward bias, these two polarity become short circuited. Then why current will flow through the D3? Because in this path the impedance or reactance is high. So, the D3 will be in reverse bias. This means during the positive half cycle number 1, only the diode D1 is in forward bias and D2, D3 and D4 are in reverse bias. D2 and D4 are reverse bias because the input is the positive half cycle and polarity is directly reverse bias the diodes D2 and D4. Now, I am going to discuss one by one. During the positive half cycle, already I have discussed D2, D3 and D4 are in reverse bias. This means these 3 diodes are open circuited. Now, on the other hand, D1 is in forward bias. This means this is ideally short circuited. Then C1 will get charged in the clockwise direction and voltage across the C1 is become Vm. Why Vm? If we apply KVL, what will be here? If we apply KVL, then KVL equation will be like this: Vm minus Vc1, this is equal to 0. This implies Vc1 is equal to Vm. Okay guys. Now, during the positive half cycle number 1, C1 gets charged till voltage Vm. Now, half cycle number 2. Half cycle number 2, that half cycle number 2 is the first negative half cycle. Half cycle number 2 is basically the first negative half cycle. Then what will happen here? Obviously, the diode D2 is in forward bias because the positive polarity of the input signal is connected with the P and negative polarity of the input signal is connected with the N, because this side this is N terminal and this side it is P terminal. So, obviously D2 is in forward bias. And now what about the D1, D3 and D4? Here D4 may be eligible for forward bias, but the D4 will be in reverse bias. Why? Because if D4 is in forward bias, then current has to flow through C2, C4 and C3. This means high reactance path. On the other hand, D2 has ideally already get short circuited. This means why the current will flow through this path? The current will never flow through this path. The current will flow through C2, D2 and C1 and V input only. This means only D2 is in forward bias and D1, D3 and D4 are in reverse bias. Okay guys. Now, how much voltage will get charged in the capacitor C2? Obviously, we can analyze this only. The D2 is forward bias with the voltage of C1, this means Vm, as well as the D2 is in forward bias with the voltage of V input. This means the D2 is in forward bias by a voltage of Vm plus Vm, that is twice Vm, so that the C2 will get charged to Vm. If we will apply the KVL, also we will get the 2 Vm, because we will apply KVL, then we get minus Vc2 plus Vm is equal to 0. This means Vc2 is equal to twice Vm. This means the capacitor C2 will get charged twice Vm. Now, next half cycle. The second positive half cycle. This means the half cycle number 3 is the positive half cycle. Now, half cycle number 3 is the positive half cycle. This means the D1, D2 already has reverse bias, because D1 and D2 has reverse bias due to the voltage of C1 and C2 respectively. Now, during this positive half cycle, the D3 will be in forward bias. D3 will be in forward bias. Then C3 will get charged in the clockwise loop. How much voltage will get charged in the capacitor C3? Now, if we apply KVL voltage, then what will happen here? Vc3, I am going to apply the KVL equation. Vc3 plus Vm minus 2 Vm plus 2 Vm is equal to 0. We can apply the voltage KVL equation in this loop. We are going in this loop. Then we are moving from minus to plus. This means this is the Vc3 plus Vm minus 2 Vm, this is equal to 0. Then Vc3 is equal to twice Vm, because this 2 Vm gets cancelled, and Vc3 is equal to twice Vm. Okay guys. Now this means what is the tricks? That only C1 will get charged Vm voltage, and after that the next capacitors will get charged 2 Vm, because C2 already gets charged 2 Vm and C3 already gets charged 2 Vm. Now, during the fourth half cycle, that is the second negative half cycle, during the half cycle number 4, that is the second half cycle, negative half cycle, the D4 will be in forward bias and D1, D2 and D3 are in reverse bias. That is why these capacitors are open circuited. Now what will happen here? The D4 is in forward bias. This means the C4 will get charged till voltage Vc4. Then what will be the value of Vc4? Obviously, the Vc4 will be 2 Vm. Why 2 Vm? If we apply the KVL equation, we get Vm minus 2 Vm minus Vc4 plus 2 Vm plus Vm is equal to 0, and here 2 Vm will cancel, and Vm plus Vm is equal to 2 Vm. This means Vc4 is equal to twice Vm. Now, all the capacitors has been charged. Then what will happen? After the getting the C4 will get full charge, the D4 will open circuited. This means these 4 terminals are just open circuited. In the upper leg there are 2 capacitors, and at the lower leg there are 2 capacitors, and these 4 capacitors will hold the charge. These 4 capacitor will never gets discharged until and unless externally we allow the capacitor to discharge. Otherwise, these 4 capacitor will hold the charge. Then what will happen? If we take output voltage across C1 and C3, what will happen? We get Vm plus 2 Vm, that is thrice Vm, that is 3 Vm. So that this is called the voltage tripler circuit. On the other hand, if we get the if we take the output voltage across C2 and C4, what will happen? We get twice Vm plus twice Vm. This is 4 Vm. That is why this is called the voltage quadrupler. Voltage quadrupler circuit. This is the conclusion of this circuit. In the same way, if we want to take n times of input voltage, n times of the peak value of the input voltage, we will connect n number of diode and capacitor, and we get the n times of the peak value of the input voltage. So, this is the general trick to achieve the n time voltage multiplier circuit. Okay guys, in the next lecture we will discuss the next topic, that is special purpose 2 terminal diodes. Okay guys, see you again. Thank you.